Hello friends, welcome to educators.com. I am Preeti Rathi. In last session we have discussed structures and now we will discuss storage classes in C. The topics which we are going to cover are storage classes in C, types of storage classes, automatic storage class, register storage class, static storage class, external storage class, and then we'll see storage type usage guidelines, that is when to go for which type of storage class. Now storage classes, a variable storage class tells us few things about the variable. The first is where the variable will be stored, means the location where the memory will be created. Then what will be the initial value of that variable, that is the default initial value. Then what is the scope of the variable, that is in which function the value of the variable will be available, that is its accessibility. Then what is the life of the variable, that is how long would the variable exist. These four things will get through the storage class. There are four types of storage classes we have: automatic storage class, register storage class, static storage class, and external storage class. Now when we talk about automatic storage class, so we have now when we talk about automatic storage class, so we have storage is memory. Its initial default value is unpredictable value, which is again called as garbage value. Scope is local to the block in which the variable is defined. Life is till the control remains within the block in which the variable is defined. Then we have register storage class. Register storage class is very much similar to automatic storage class. The only difference is this variable will be created on CPU register, so it will give better performance. So storage is CPU register. Initial default value is again garbage value, which is unpredictable. Scope is local to the block in which the variable is defined, and life is till the control remains within the block in which the variable is defined. Then we have static storage class. Now in this case storage is memory. Its initial value is 0, but the scope and life is different. That scope is local to the block in which variable is defined, which is same as of other storage classes, but the life is value of this variable will persist between different function call. Then we got external storage class. External storage class, the variable is created in memory. Its initial value is 0. Scope is global, means it's accessible everywhere. Life is as long as the program's execution does not come to an end. Like this, four storage classes we have. Now here we can see that when to go for which storage class. So mainly we have seen automatic is a default storage class. So if we don't provide any storage class explicitly, by default it will be of auto type, which takes the garbage value, and its life and scope is the block in which it is declared. Then we have seen register. So register is same as of auto, but the difference is it gives better performance. Then we have seen static. In static the initial value is 0. It is the only difference is its value will persist between different function call. And external storage class should be used only if we want the variable should be available everywhere, because it will have global scope. So with external storage class there can be disadvantage of misuse also, as it is available everywhere. Now when we talk about register storage class, so we should use register storage class for only those variables that are being used very often in a program, because CPU register is limited. So sometime if it is not available, then the register will become automatically as a auto type. As register CPU register is limited, so we should make careful utilization of the scarce resources. Now for example, we can use this register type for the loop counter because frequently we want to access that value. So this way we can decide when to go for which storage type. Now we'll check out all the storage classes practically. Now in this example, again we are having hash include of stdio.h and conio.h. Then we are having main method, which is the entry point of our application, clear the screen and get ch. Now if I have one variable initialized or declared in a block, that is integer I equal to 100. Now by default if I don't specify anything, it is of auto type. We can even explicitly specify that. Now this value will be available inside this block. That is, if I can print here I equal to %d. But its life and scope is only the block in which it is declared. So after this block, if I try to print the value, I'll get error. Now if I'll compile this application, I'll get error for the undefined symbol I, because the I is available only into this block. This shows that life and scope of this auto variable is only into the block in which it is declared. Now its default value, if I don't initialize this value, then it will acquire default value, which is a garbage one, which will be randomly given. So it can be any garbage value. So by default, auto type holds the garbage value. Its life and scope is the block in which it is declared. Now these rules are same for register also. Now as we have seen, the only advantage of register is it is saved on CPU register, so it will give faster access. So it will give better performance. Rest everything is same, that the initial default value is again garbage here. Then if I initialize it to something, its life is only the block in which it is declared. If I try to read it outside, we'll get compile time error, that is undefined symbol I. So sometime if register is not available, then automatically it will become auto type. Now the third storage class is static. Static, we have seen, it gets initialized to 0. Its life is throughout the application, means its value will be retained between multiple function call, and scope is the same block. For example, I have some function, say static demo, and inside this function if I have a static variable, static integer z equal to say 100, then I'll display this value, that is printf z equal to %d with the \n for new line, and then we will increment value of the z. Now if I call this function multiple times inside main, say I'll call this way, static demo, then one more time I'll call it, and say one more time. So 3 times I have called the same function. So if I'll execute this, we can see here that value is retained. Initially it was 100, then increment to 101. So next time when we call the function, that value is retained, reinitialization to 100 is not done. Again it will be incremented by 1. So we can say the value of static variable will be retained between multiple function call, and this reinitialization to 100 will not be done. If I remove the static keyword, then it becomes auto. So we'll not get this kind of behavior. You can see here every time z is becoming 100. Even though z is incremented to 101, once that function is over, that value will be lost. And again when second time we call the function, it will get reinitialized. Now as we have seen, if I don't initialize this static variable and I'll execute it, still it's not giving any garbage value, that is unpredictable, but it gets 0 as the initial value. Second time it will give 1 and then 2. So this is about the static variable. So if we wish to retain the value between multiple function call, then we can use static variable. Now finally we'll check out extern type. Now as we have discussed, extern is of global scope, which is available everywhere. It gets initial value as a 0. Now suppose I have a file where I'll keep some extern variable, that is say integer exval, or say ex equal to something, say 101. And now I'll save this file with .c extension. Say demo.c. Now I'll create another file. Now in this file we'll have again hash include stdio.h, then hash include conio.h. Now here that variable I want to use. So for that we have to include that file, as the file we have created here is in a local drive only. So we have to give the path in double quotes. That is, the file is demo.c. And then we'll declare that we are having external variable of name ex. Now this variable we are free to use in our application. Say we have main method where I'll have clear screen and then I'll display that variable. This way. Then we'll have get ch to retain the screen. Now if I'll execute this, so we can see value is defined over here. That is, value is we are available, that value is available globally now. So that is what extern we have, means we can declare it once, define it once, and can access it anywhere. So its scope is global, everywhere it is available, its life is till the program executes, and its initial value is 0. So that is all about 4 different type of storage classes we have seen. Now we can decide when to go for which type depending on our requirement. For example, if we want a variable to be accessed frequently, then we can go for register. But every time we will not get behavior of register. If register is full, it will behave like auto. If we want global access of a variable, we can make it extern. But again we can have misuse of it, so we need to monitor that. If we want to retain the value through multiple function call, then we can use static. And finally auto is frequently used, which is a default type also. So most of the variable has storage class as auto. So this way we have discussed storage classes. Now in next video we'll discuss preprocessor. Thank you.